for coming along. We've got Steve VK7OO, who for 14 years? Almost 14 years, has been running a 20 metre SSTV cam, which he'll explain what that is. And what you're seeing here is a selection of the over 120,000 images Steve has
there's some automatic way that these are collected. You don't have to.
He'll let us know about that.
Tune into every one or something.
But I thought it was good that Steve came along and actually gave us a bit of an idea about, first of all, SSTV, but also what it takes to run a SSTV cam for 14 odd years. And then Steve's actually going to finish off with a bit about his PEX, aluminium PEX, which is gas pipe, magnetic loop. So without further ado, welcome Steve.
Right, good evening. I must admit I have an obsession. I'd like to start by saying I'm not an expert. There are people in this room that are far more knowledgeable than me on many subjects. So this is more about my experience and a lot of fun I've had along the way. So, firstly about me, first licensed in 1983 as VK2XOR. If you were a VK2 limited license in those times, you had to choose an X course sign. 1988 I moved to Hobart and became VK7OO. Didn't realise at the time the implications of that, but I ended up being the first limited in the state that wasn't a Z.
Okay.
So that was fun. Anyway, and in 2008 I participated in the ballot for a 2-letter call sign. I took OO on the basis that I liked 7 Echo's call sign. I thought it was very melodious, so I tried to find something that was similar. Okay, so once upon a time, in 2007, and I don't remember who, but a very enthusiastic person introduced me to SlowScan, which I've never seen before. I'd done digital modes before, mostly RITI, but never seen SlowScan. So, but I thought, that's nice, but I'm not sure that I'm interested in doing that. It just didn't grab me. And I think he picked up on the fact that it did grab me, because then he showed me SSTVCams, and I was like, yeah, I could do that. And it did grab my attention. So an SSTVCam is basically somebody who receives images off the radio and immediately posts them automatically onto the web. So this is VK4 MOD, and that's recently. That one is VK6POP. Now he chases a lot of DX, so it's interesting the page he has. VK3HJB in Victoria as an example, and they are existing in Tassie as well, so that's 7BO up in the north of the state. So, and there are hundreds of these things around the world, literally hundreds of them, which is really fun because you can send a picture and see just exactly where it lands. There are also index pages. This particular one is VK6AAL, and he will grab images from all the web pages that are up there online. So basically, if you run a webcam online, most people who run web pages don't want other people pinching their images, using their bandwidth to display images on another web page. But where SlowScan is concerned, you actually want people to do that. So we all openly share our images. The journey begins. It took me 24 hours and I was on air. And that's what my first website looked like. And those are the 3 oldest images that I can find on file from March 2007. So, and fairly quickly I updated it a little bit and did a few things. You'll also see here where it says best pictures I received in March 2007, which I actually did. I only ever did that once because it took quite a while to do, and I thought, no, I'm never doing that again. About a year later, I got sick of the look of the site, and I got sick of the look of all the SlowScan sites because they look very bland. And I went for something a little different. So black background, something that looked pretty snazzy and actually displays the images better. So they look better on a black background than a white background. And this is what the page looks like today. So I've stuck 7KRJ's 20 metre image down the bottom left corner there. I'll tidy that up later on, but it's just been put up there fairly recently. When I get time, I'll fix it. Okay, so what do you need to run slow scan? Well, with all digital modes, you want an antenna, a radio, a computer, and a program. When you want to run a cam, you don't need a transceiver, your receiver is fine. You can use SDR, which I've been playing with lately. But your slow scan program needs to be able to save files. That's crucial. Now, SSTV by default doesn't do that. It needs to be set up so that it can. Not hard, that's the matter of getting through the process. You need internet access. That's not a problem these days. It may have been a little bit of a problem for some people back in the early 2000s or even the 1990s, but not a problem these days. And a hosted website. And that can be a bit of a problem. Again, back in 2007, all ISPs provided web pages for people who had services. They don't do that anymore. So if you want a hosted website, it might actually cost something, or you might have to come to some arrangement with somebody. 7KRJ has got a webcam up recently, and he self-hosts. So he has a fixed IP address at his home, and he has it all running internally. And the most crucial thing is something that will upload your images. Vast majority of people out there use the KE5R SFTP widget, and mainly because it works and it's easy to use. But you could write a script in a Linux bash, or you could write your own program. It's not that difficult. It's pretty straightforward. So, 13-year journey. It's been a lot of fun, and it's been something that at times are challenging. One of the biggest problems with SSTVCams worldwide is dedication. So many people put up webcams and they use them really well for a year or so, and then they just walk away from them and leave me. Or they just don't bother to update them, or they take no interest in slow scan again. This image there is part of an American site, which is an index page. And you can see there's only 3 images on that page that are still active. And if you look down the bottom right hand corner, VK7OO, I took that web page down in 2008. But that was taken off his site a few days ago. So that's been how long since he's updated that page. His dedication was not there. Uptime is another thing. If you're going to play slow scan, and if you want to do what I did, which is dedicate to doing it all the time, actually takes a bit of effort. So, bandwidth. I discovered bandwidth is a problem. So if you have a hosted website, along with that hosting plan comes a certain amount of bandwidth, which isn't all that much. And I found after a few months that my web page would become unavailable for a few days each month, always towards the end of the month. And each month it just got more and more and more, and I thought, what's going on here? So I went and dived into it to see, well, people must be accessing the website, because straight away I figured out I was exceeding my bandwidth for the month. This is great. I go and look, index page, no access, index page, no access. It looks like people weren't accessing the pages. Then I looked at image 1, and its bandwidth was through the roof. Like people were accessing the images and not the page. So okay, fair enough. And the reason is, index pages is one of them. The index page is accessing image 1 on multiple websites. But also you can get programs like this one that run under Windows, where you can program in all the webcams you want to look at. And so there are sites around the world that are refreshing my image regularly, and we're talking every few minutes, and that's where the bandwidth was being consumed. In fact, here I'm showing the last 15 images on my site through that program. So that was a problem. I fixed that by moving the images off my web hosting service onto my ISP's homepage, the homepage that they provide me, which they give you unlimited bandwidth for non-commercial use. Well, it's non-commercial use, so that was fine. They've never ever questioned me. Other challenge to keeping a slow scan webcam going is antennas. I find that the antennas break. You put an antenna in the air, it's not going to stay there. So that's a problem. Receiver sensitivity. Well, the IC730 lasted around about 10 years before it came to notice that it really wasn't doing a very good job. So I don't know what happened to it, but I haven't got around to fixing it yet, but it's not nearly as sensitive as it used to be. FTP Access. That's been somewhat of a problem. If you can't access your website, then you can't upload images, and you need access all the time. In my case, when I moved it on to my ISP's page that they provide me, they suddenly turned around and decided they weren't going to do that anymore, and they blocked everybody's access on FTP without telling anybody. So a lot of people complained, and gradually, one by one, they would put it back. But that was a problem I had that I couldn't get around, I couldn't control. QRM and QSB. That graphic at the bottom, the one that's moving, that's just a dozen or so images sent by the one station in an afternoon, and each one's got a different amount of QSB on the image. Some people ask me, what do all these bars, these dark bars? They're just QSB. And on 20 metres that can be quite deep and rapid, so you get these very thin lines. The one at the top, I believe to be plasma interference. And that was another challenge that I faced, because I was using the antenna that was located between my house and a block of flats, and that was fine for about 6 months until I started getting massive interference, and I had to abandon that antenna. And of course moving home, which is something I've done twice in the last 3 years. There's not a whole lot you can do about that. It's downtime you can't afford. Although you can't avoid. So how much power do you need just to send slow scans? Because I got asked this question once before and I didn't answer it very well. So you don't need much, which is good for the foundation licences. But 10 watts will get you a reasonable distance. Now, fair enough, that picture would have been in time when conditions were reasonably good. At the moment, conditions are dreadful. So probably wouldn't get you very far. But if you use a bit more power, then you can do better. The IZ1 MKE is one station in Italy you will always hear. If Europe is open, he is there. And the reason you look through there's nothing special about his radio, there's nothing special about the antennas, but there is something special about his 500 watts. That gets him through. Or you could use a big antenna. Quite common, we know, with American stations, they have high power and often very big antennas. So there's also a select number of North American stations that you will always hear when the DX is there. And then there's this guy, I call him this guy, R3NA. Haven't heard a peep out of him for 3 years, but he would be there when no other station could get through. Always, always there. And the outstanding thing about him was that he was plonked in the middle of Russia. That's him up there, a few hundred kilometres northeast of Moscow. So not in Europe, not in eastern Russia, because eastern Russia you get quite fairly often on the Pacific coast. You can get that fairly straightforward. But this part of Russia, he was the only station you'd ever hear. And like I said, it was always there. If there was even the slightest amount of DX, and it didn't have to be much, and he'd punch his way through it. So propagation on 20 metres, since I'm an expert on 20 metres. No, I'm not. I've sat on one frequency for 13 years, I know a little bit about it. One thing that you will find if you do operate slow scan on 20 metres, that you will almost never hear both sides of the QSO. You'll hear one end of it, and you'll know who they're talking to, but you'll usually not hear both sides. And that's common. So that's unusual for me to have the images from both sides. It's not very much. This is a map that I drew up probably 7 or 8 years ago. The white circle going through Adelaide and New South Wales, South East Queensland. Under normal DX conditions, you will usually hear stations within that area. Always. The larger circle, you'll hear those stations, but not as often. But inside that darker circle, at the middle where Tassie and Victoria are, you hardly ever hear anybody in that zone. So once you get outside of, say, 20 kilometres from Hobart, Tassie doesn't exist, except for occasionally. So that's the only image I've ever received from VK7OO. He is very active, and I see people talking to him all the time, but I can never hear him. And the same with VK3. That particular image from VK3 is unusual. Mostly their images are quite weak, if at all, but generally you can't hear them. That's 20 metres.
I hear him all the time on 630 metres.
30 you might? 10
No,
you would?
630.
630, yes,
Yes.
but not on 20.
Okay.
It's like this big dead zone, and it starts at New Norfolk.
Yeah, okay.
There was a station at New Norfolk, but never hear them. Never ever hear them.
What bandwidth do you run?
Sorry?
What bandwidth?
Bandwidth?
Yeah.
This is just standard sideband.
Yeah.
And you use the whole bandwidth?
It uses most of it, yeah.
Huh?
From 1200 up to 2300.
I would have thought with slow scan you could run just a couple of hertz.
No, slow scan sends a marker on 1200, and then it sends the image data between 1500 and 2300.
Do they ever send very slow so they can use narrow bandwidth?
Different modes, but no, not the bandwidth is always the same. That's the standard. So it uses from 1200 to 2300. That much bandwidth.
I mean, it seems to have the potential for a sort of a whisper type mode, doesn't it?
No, it's not a whisper mode. It's a mode where you want to use as much power as you can.
Yeah.
It's not a low power mode. Right, so my favourite contact was always with VK5HJS, simply because he was in Cooperpedia and he always sent stunning images, and his images were always that clear. Didn't matter, he was always very strong. And that was in the early days, so it sort of encouraged me a lot. Best DX was to this guy that I could find on file. I thought I had a better one, but this one, near perfect image from a station in Martinique, all the way over there. So pretty happy with that one. And I don't chase DX. I don't go looking for it. It just, if it's there, it's there. So I was pretty happy with that one. And comments on the slow scan cam are fun. So someone says thanks for the webcam, that's good. But this VE3YCO put that image up one night, good night Hobart, sent it during the day in North America. He was clearly talking to me, even though I wasn't there. I found the image much later. I thought that was funny. Okay, so from space, if you want to work the ISS, it's actually not challenging at all. You just use the same radio that you rag you on and hook it to a computer, and you've got the ISS. There's nothing hard about this at all. Those images were from, I think, 2008, maybe 2010. These images are from the other day. They're currently sending these pictures for the next few days, and it's easy to do. And now literally the radio that I normally talk across the river on with my relatively high gain collinear antenna, which is not the right antenna for doing this sort of work with. So I put up to the computer and away it went. It's not hard, it's easy to do. Aerosat 1 though was a different kettle of fish. Little CubeSat, well not quite a CubeSat, it's a, what would you call that one, Justin?
A box set.
Box set. It was meant to be a suit sat, but they changed the design into a box sat, and that's it there. And it was meant to be launched, but it ended up being pushed out to the back of the ISS during a spacewalk. In the process, they broke the 70 centimetre antenna, so the crossband repeater never worked. But all the 2 metre stuff was still working. So, and it was only up there for a few months. But a lot of fun. So these aren't my images, by the way. These ones I stole from VK4OO. You happen to have them online. It would send images taken from its own camera, so you get real pictures from space, which is pretty cool. I put up a page. That's the last image on that page, which I created. A little bit sad that the thing re-entered, because it was a lot of fun doing it. And this is the system that I used. So I didn't have a radio that was cat controlled, so I had to use an SDR, and Soft Rock SDR was affordable, and hooked that into a laptop running 2 SDR receivers, both of them controlled by a program called MyDDE, which took its information from Orbitron, so the satellite tracking was done automatically by the laptop completely. Not that it was steering an antenna, because I was just using a J-pole. Nothing special, just simple quarter wave antenna. But it would do all the Doppler shift and stuff like that. So one of the receivers, the one at the top, HDSDR, was tuned to the telemetry frequency, and through the onboard sound card it was plugged into another laptop which did the decoding and uploaded that information to Arensat. The other SDR-radio was tuned to the SSTV voice frequency, and its output went into the virtual audio cable wherein the SSTV picked it up, decoded the images, and they were uploaded automatically onto the VHF web page. So a lot of fun. I never got any really good images, but I did get quite a few. So other people did better than me because they were using better antennas. But this system was completely automatic and looked after itself. More challenging when the satellite got close to re-entering because the orbital data kept changing very rapidly. So I was getting in there manually updating it. The automatic updates just weren't fast enough. But it was fun. So I hope to do that one again. Now, antennas. Well, they said you need a decent antenna. Well, back in 2007 when I started this was my HF antenna, a G5RV. The centre of it was 10 metres in the air, but the ladder line, which is 300 ohm ribbon, the last 3 metres of it was horizontal across to the house, and my coax was RG6, and my ugly balun was cable wrapped around an ice cream bucket. And I transmitted all HF bands on this, well, from 80 up anyway. The one end of it, the right hand end on the picture, was up in the back corner of the yard on a 6 metre pole. That's as high as I could get it off the ground. But the other end, which was downhill from the centre, was in the front yard, and so putting it high off the ground wasn't an option, although generally it was 3 metres off the ground. It worked all right, and it did me for a few years. But the problem with that antenna, as I said, reliability with antennas is not a great thing. 300 ohm ribbon isn't very durable, and it kept breaking, and it would break at the top of the pole, which was a telemast, a Hills telemast. So Armstrong method, get it up and down. Had to do that every year or two. I got sick of that. So I improved it. Still the same antenna, still on the same pole, still the same elements at each end, but now I had solid copper vertical, which was on spacers, and that came 10 metres right down to, oh, by the way, I'll go back to that if I can. At one point I put the centre of this 12 metres off the ground, so I raised it 2 metres, and I easily lost 6 to 10 dB of performance. Quite dramatic. Very, very quickly put it back down to 10 metres. So I think G5RVs do not like being inverted. So this is definitely a compromised antenna. So, having put a auto tuner at the bottom of the feeder, literally on the ground, so it came down the side of the shed, the wires went into the shed straight into the auto tuner. Coax off to the radio, which was now RG58, and I could tune up on 160 metres with this, so it was a good multiband antenna, and natively resonant on 20 metres wasn't a problem for slow scan, it was good. But a few months later I noticed that I had a constant S5 noise on slow scan. It was always there, and a quick look discovered that it was only on 14230, nowhere else. So, right, something's interfering with us. I go hardly, madly hunting around trying to find the interference. Turned out to be the auto tuner. Not the power pack that powers it, but the auto tuner itself. So the simple solution was just to turn it off and just let it sit there, not doing anything. On 20 metres, that was fine, especially for receive only, that was fine. If I wanted to use it for anything else, I turned the tuner back on and away I'd go. So this was the antenna I used during the RD and various other times, but 99.999% of the time it was doing receive on slow scan. So that was good fun.
Do you know what was causing it in the tune?
The tuner itself. It was the circuitry in the tuner. microprocessor. It had little birdies all over the place.
Yeah.
One of them was on 14230 and it never moved.
Okay.
Well, it moved a tiny bit, but it basically didn't move.
Okay.
So,
Excuse me, what brand tuner was it, out of curiosity?
SG230, I think.
Okay.
Yep, 100 watt tuner. Now, I've been mucking around with magnetic loops for quite a while, but I would say most of the time not very successfully. This is my first attempt at a loop on 20 metres. It did work, it was extraordinarily difficult to use and it didn't perform very well. So on my first QDH relocation, that was what I was trying to use to keep the cam on air inside the house. It didn't work very well. In fact, I borrowed one off Robbie, VK7OO, which he loaned me, and similar design, but it worked a bit better than that one. So that one's sitting in the corner at the moment, not doing anything. But 2016, VK5SFA, a good friend of mine, in fact he used to be my manager, convinced me to build one of these. That's his on the left, and the design, part of his design there. So this is a 2-turn mag loop for 160 metres, and it'll work 80 metres as well. But principally it was meant to work 160 metres. 3 metres in diameter, it's a monster. But he convinced me to build one. I already had the coax, I already had the vacuum variable capacitor, so I thought this won't be overly expensive. I was wrong. That's my antenna, after it was in the air, completed. Pretty happy with it, worked quite well, and I got a very good result in the RD using that. But, as I said, I already had the capacitor, but the amount of time and effort that went into constructing that arrangement there with limit switches and whatever else, even though the gearbox on the motor was already there, I couldn't use the motor that was in it. I had to remove the motor and come up with something else. Also had to build the PVC piping structure and spend many hours doing it. This was a massive job. I'd be working late at night, I'd spend days and days on it. It was a lot of work and it ended up costing quite a few $100s, so it wasn't a cheap antenna. So, when I spotted this in the AR magazine, I was very interested. An antenna or a mag loop for $54, I said, wow, that looks good. Turns out that's almost the right size for 20 metre antenna. So even though that design is for 40 metres, then very quickly adapted to 20. And that's it. So this is the pipe that we'll use, 25mm Texal Tex. Internal layer of HDPE plastic, it's quite hard. Then a layer of aluminium, which is about 0.3mm thick. And outside layer of HDPE that's had clay put in it to give it the yellow colour. If it's yellow, it's gas pipe, it will have the aluminium layer. Any other colour will not have the aluminium layer in it, so if you do want to buy some, you've got to go for the yellow stuff. Now, these 6 metre rolls used to be sold in Bunnings. You can't buy them anymore. Gas Type, the company that makes them, still do sell them in 6 metre rolls. It's a question of finding them. But locally you can buy this stuff in 50 metre rolls or in 5 metre long straight lengths. So 5 metres is almost enough to do a decent antenna on 20 metres. I use 5.3, so you know it's good. So that's my antenna after I finish. So you can see my design sort of looks like that one, but I made a few changes. Nothing significant. The basic idea is still the same. Most importantly, my trombone capacitor is hidden inside the pipe. Visually it's more pleasing. So off I went to 66pacific.com, which is my favourite website for designing mag loops, mainly because this website seems to give the right result. There are other calculators out there, but they don't give the same result. Now maybe they're designed for square loops or whatever, but this one seems to work for round loops quite well. So my circumference of choice, 5.1 metres. Anything more than 5.1 metres won't work on 20 metres. So 5.1 is your maximum circumference. The pipe turns out to be it's 25mm pipe, but the diameter of the aluminium layer is 23 millimetres, so 2.3 centimetres. My frequency of choice is 14.23. Hit calculate and I get the results on the right there. And the thing we're interested in is the tuning capacitance of 13 picofarads. I'm not really interested in the rest of it, but that's what we needed to design the antenna for. But I thought, well, how much capacitance variation do I need? So I went and did the same calculation for the bottom of the band, and my 30 picofarads turned to 31 picofarads. I thought, holy crap, maybe 2 picofarads from one end of the band to the other. That's going to be really, really tight tuning, really tight. So I wasn't too keen on that. So the basic premise is that 19mm or 3/4 inch copper pipe is a very neat fit. If your PEX is round and straight, then that will move in and out quite freely. If it's not round and straight, then you're going to have the problem I've got there, it's a little bit stiff. But Jim, VK5 JST, calculated 624 picofarads per metre for that capacitance. I wanted 30 picofarads, that's 48 millimetres. And 1 picofarad with 1.6 millimetre variation, so from there to there, it was tiny. Not very good. So, trombone capacitor, we've got 2 of these in series. So, this is a mock-up, so imagine that this is the top of the loop going out. That's my trombone. So now we've got 2 of these in series. So, 2 60 picofarad capacitors in series, we needed 96 millimetres, around about 100 mil. 1 picofarad now, 3.21 millimetres of variation, which is still not very much. So in my head I'm thinking, I've got to make this easier to tune, and the obvious way to make it easier to tune is to cut your pipe in half. So I cut the pipe in half, joined a little bit back onto the end of it so that it was still round at the end, but that's my trombone section, or my tuning section.
Just hold it up again, Steve.
So that's it there. Am I in the picture?
Yeah.
Right, so now I've just chucked that in the vise and cut it in half, and it's not even a straight cut, but it doesn't matter. Whatever's wider on one end is narrower on the other end, so on average it's going to be about the same. So we're talking about 6.4 millimetres per picofarad, so 6.4 millimetres, maybe maximum 1 centimetre from one end of the band to the other. That's doable, because we're going to stick a thread on this and we're going to use a thread to control it with. So that's doable. But now the length of the trombone is 192 mil. I didn't use 192 mil, I used 120 mil, and it worked. And I think the difference is the capacitance between these 2 pieces, which is not taken into consideration. So I'm guessing there's 10 picofarad just between these pipes being next to each other. So that's probably where I made the difference. My calculations I did at the time I couldn't understand, and when I went looking at them the other day, it's like, do it all again, they came up with different numbers. So the capacitance between each leg is an unknown, but let's say it's about 10. So now this is the top of my antenna without the plastic pipe on it. I mounted a piece of 12mm by 32mm hardwood behind it, and that fits very nicely inside 50mm pipe, so that you can now put everything inside that 50mm pipe, seal it where it comes out the top, and it's waterproof, dustproof, and it looks good. So that works well. I'll hand that round so you can have a look at it. So you can see down there, there's a copper pipe going through there, and just plastic joiner to a length of pipe. I don't like having my motors inside the loop. I put them outside the loop. So down the other end of that white pipe, got a limit switch there, and there's a captive nut inside the pipe with the thread down the bottom. So it's very basic. It's just you turn the thread, the pipe goes up and down. Down the other end is the motor with a flexible coupling and another limit switch. So that all fits inside a 50mm pipe, completely hidden from view.
Is that a stepper motor?
No,
No.
it's just a DC motor, and this is the circuit that I used to control it with.
Okay.
So it used to do the tuning, and it is nothing more than a $6 pulse width modulator from eBay. I've just put a couple of relays. I took the forward backward switch out of there and put it on here. That's easy to use. Nothing to it. So pretty straightforward. The relays are controlled by the limit switches. I've got 4 LEDs on there so that I know the limit switches are working and responding, and red or green depending on whether they're up or down, so I know when I've reached the end of the run. You just watch your antenna analyzer to see where you are. So pretty straightforward, especially when it's the longer on frequency and leave it there, it doesn't matter. So very happy with it. And it works. Now, because I've moved QDH, I couldn't compare it to the G5RV because I was using it in a totally different QDH altogether. So at the time I couldn't tell. I got the impression that it seemed to be better, and the way that I determined that it was better was because on the G5RV I could hear a slow scan signal, but SSTV wouldn't decode it. With the mag loop, it was decoding messages I could barely hear. So that sort of told me that yeah, it does work better, it's more sensitive. It doesn't always produce droopy pictures, but anyway, recently I've done some comparisons because I now have multiple antennas at my current QDH. So for the last few weeks I've been running comparisons, putting the mag loop up against an 80-metre end fed and my 54-metre Beveridge. Now I'll excuse the Beveridge from this as being a reliable antenna because it works really well on 40 metres, but it doesn't seem to do so well on 20, and it's aimed in the wrong direction. So it's not going to perform that well, but it did do reasonably well. Consistently, the mag loop has done a better job. On occasion, the 80 metre did better, but the mag loop consistently does better. It doesn't do as well as the 20 metre dipole, so 7K RJ, for instance, usually will do a better picture than me. And Robbie, MAG, usually has a fairly good run as well, but that could be my QDH, I don't know. I'm not in a position to make that assessment, but it seems to be the better of the antennas I have available to me anyway. Now, slow scan in 2020. Been a bit of interest this year, partly driven by the fact that foundation class can do data modes now. So a lot of the foundations are playing with slow scan. New webcams have appeared, VK7MAG and VK7KRJ. So Robbie's webcam is a collaboration that he and I put together. The idea was put up, someone said to me, why don't you put up a webcam on 10 metres? And I said, well, I would, but I can't. At that point in time I was in a temporary QDH, so and Robbie said, well, I can do it. And I said, well, okay, you can do it and I'll do the web page for you. So that's it. So we've just took my web page and modified it to do what he does. Now he moves his between 10 and 40 metres, he's nearly always on 10. And 7KRJ has gone nuts and put cams up on as many bands as he can manage, including he added the ISS in the last couple of days. So he's on 10, 15, 20, 40, 80. He said 80 metres is almost completely dead, but the other bands have some activity. So he's quite into it. He's put a lot of effort into it, and he's still only in the development point, so we don't know where he's going with this one, but it'll be interesting. The ISS over the last year or two has been having a lot more slow scan events. As I said, there's one currently running. This is the media release about it for the current one. But yeah, so there's a lot more stuff coming out of the ISS, which is easy to do. So and a bit of fun, and you can get a certificate if you want. And I'm also starting to get back into it. Like for most of the 13-year journey, my webpage has hardly changed. Recently I added on to every image an information footer into the image itself, so it's part of the image. And the reason for that is twofold. One is because people generally, when they're watching, are only watching the image and not ever coming to the web page. So there's pointless putting information on the web page. People don't read that, but they will see that because then they're grabbing the image, they'll see the footer. They can tell them some information about what's going on. If I change antennas, I can put up information. I've changed antennas. If I change radios, I can put that in there as well. Most importantly, if I change frequency, and that's what I plan to do. So I will run multiple receivers in 20 metres on different frequencies. I've been planning to do this with an SDR program. Finding one that will handle multiple receivers reliably has been the challenge, but I think I've got it. So the latest release of SDR console has had a significant rewrite, which has made it a lot more stable. So I've been running it for the last week or two. It's been fine. So I'm now ready to start branching out into multiple frequencies, which is in itself going to be a challenge because the FTP aspect of it is something serious that I have to consider. The FTP access onto a website with one user at a time. And Robbie and I sometimes go in at the same time and one of us loses. It's usually me. So, bit of a pain. Oh, that's it.
Questions?
Questions?
For Steve.
How long does it take to get a picture down?
In black and white, 8 seconds. In colour, anything up to 2 minutes. Depending on the mode, it's entirely mode dependent. So the most common mode used is Scotty 2, which is about 30 seconds. The Scotty 1 is a better quality picture, but the same resolution, takes about a minute. The ISS has been sending PD 120, which I presume is 2 minutes, I'm guessing. I haven't actually timed it. But their images are much larger. They still can't read them very well, but they're much larger. They're using font that's extremely small and not really suitable for the image. Anyway.
Does SSTV automatically detect the mode?
Yes. It will automatically detect the mode from the header, or what they call the viz signal, the line sync. It will also detect it from the individual line sync. And you can set it to do one or both. Ken's discovered on 80 metres, for instance, that you don't want to detect on line sync, you want to detect on viz only. Otherwise you get massive incorrect decodes, just picking up noise and thinking it's a signal.
Yeah.
So, and that's the problem with any slow scan running automatically, is you'll get a false trigger and you'll just go ahead and receive noise thinking it's in the mode. But yeah, it will determine the mode for you, or if it doesn't do a very good job of detecting the mode and you're used to the sound of it, you can click on Scotty 2 and it'll start doing Scotty 2. If you've got the mode right, your picture will appear. If you've got the mode wrong, it'll just look like crap. Which does happen.
The other thing is slant detection used to always be an issue. Slant correction.
Slant correction? Now slant correction by default is automatic. So when the image comes in, MMSSTV will look at that image and make adjustments to get it nice and straight. But most people that run webcams prefer not to do that because you're hiding any errors that people have. So it's helpful, if, for instance, if I don't have automatic slant adjustment turned on and someone sends an image that's not straight, got a bit of slant, they can look on the cam and see, okay, my image has got slant, and then they can start correcting for it, and people do that. VK7OO, for instance, has always been a straight image, but the last couple of days he's been sending with a slant, and he can see that now he's sending with a slant the other way, so he hasn't quite got it right. But
Overcompensated.
But he's working on it. But we had some ZLs recently that were sending slants, and it took them a while to figure out that they weren't quite straight. But that depends on me being straight. That's not a problem. I've found that once you calibrate your equipment, it tends to stay there. It doesn't. Any variation is not significant. We're talking about less than a hertz variation. It's very difficult to see on the images. Sorry, a quarter of a hertz is visible, but I don't think it moves that much.
So there is a calibration process you go through.
There is a calibration process. You can do it manually, or you can listen into WWV and go into the calibration screen, which will then put up a screen full of a black screen full of noise, but in that noise you'll see a line, and you've just got to use that line as your calibration. This is just a matter of click there, and it goes, yep, make the adjustment, and then you can sit there and watch it get longer to make sure that line's nice and vertical. Once you're happy with it being vertical, that's your calibration, you're done. So as far as receive goes, transmit shouldn't be a problem. Sometimes some computers, their transmit clock or their sound clock on transmit is different, so there's a compensation for that as well, but I think that's pretty rare these days. Older equipment it did happen on, I don't think it anymore. And if you're using SDR, then you can set the clock to 1200 and you don't have to touch it, because the SDR is not running a computer sound card, it's running through VAC, for instance, which is absolutely rock solid on 1200. So that's I'm not answering that.
Given you've been listening on 20 metres for 14 years, nearly 14 years, have you seen the Sunspot cycle, the 11-year cycle?
Okay, 2007, conditions were pretty good. By 2010, conditions were really good. By about 2012, I had established this concept of propagation, where you'd always hear southern New South Wales, you'd always hear Adelaide, you might hear north Queensland, but you'd never hear Victoria. That was established, and that was well and truly there, and then you'd get the DX would be random. But the local DX was quite reliable, and yes, it was there. In the last 2 years, there's been absolutely sweet FA.
Yeah.
You cannot hear anything outside of Hobart quite often. And getting stations further away is challenging. But in the last week or so, there's been an opening in the JA. Now, we haven't heard JAs for ages and ages and ages. But they used to always be there, but not for a long time. So yeah, there is that definite cycle, and we're certainly in the doldrums at the moment. It's there. The other thing I noticed, which was quite weird, Sunspot Activity, because I also have an interest in auroras, so I'd always pay attention to sunspots and their impact on the corona around the Earth, so that when there was an active aurora, 20 metres would just collapse. There'd be nothing, no DX whatsoever at the same time. So it has the opposite effect of what you thought. You think, oh yeah, great, sunspot cycle, and there's going to be an impact that's going to cause an aurora, that'll make good DX. Not on 20 metres. It has completely the other effect.
Steve, it's the same on 630 metres.
Yeah.
Leading up to that event, you have fantastic 630 metre propagation, and then nothing.
Yeah. Yeah. That's 20 is the same. I'm not sure about how well it was good leading up to it, but certainly at the time and for a day or two afterwards, it would just be dead.
Yeah.
Absolutely dead. Yeah. But the other thing too with slow scan is that you're totally relying on people sending, and if they're not sending, you can't tell what's going on. So unfortunately, it's not like FT8, it's not like Whisper, it's not like Sideband or anything. It's generally a select group of people that are sending it. So if they're not active, then you don't know what's going on. Yeah, that's the other thing.
Another question relating to your long-term listening. Have you noticed a change in the noise floor, allowing for different QTHs along the way as well?
The magnetic loop is very quiet. That's noticeable. 20 metres generally is quiet. Even on the G5RV, it was always either 0 S points. At the noisiest, it was 5. Not a noisy band. So I always found 20 metre great. I liked it in the RD whenever I'd get on to 20 metres, especially if there was a station in the southern VK4. It's like talking on telephone. I used to like doing that. So no, 20 metres is a very quiet band, so it would never ever be very noisy. It's good. Okay.
With the band loop, where does the radiation come in and out?
Okay, so assuming this is a single turn loop, that's your point of radiation, and when you're side onto the loop, that's your null. So basically you're transmitting a donut. If it's vertically polarised, if it's vertically mounted as a horizontal antenna. If you mount it like that, it would be a vertical antenna, but you would need to have it high off the ground, whereas mounted that way you can put it close to the ground and it doesn't make any difference to the performance.
What's the radiation bandwidth? Are they narrow?
The bandwidth on a mag loop, it all depends on the mag loop. For instance, my 2-turn loop for 160 metres has a bandwidth of 3 kilohertz.
What I mean is like beam width.
Beam width?
Yeah.
Very similar to a dipole. It's
Wow.
not wide, but it's very similar to a dipole. But you could think of it as being a round dipole. It has that kind of radiation.
So you don't have to go like 1.25 of a degree.
I've got
Right. So it's the null that is.
the null that's in the plane
Yeah.
is very deep, and so you could turn that and potentially null out a local interference source,
Right.
which a lot of people talk about. I've never done it, but that's what they say. I mounted my antenna initially in my current QTH so that it was aimed north. My neighbour immediately complained and told me to take it down, so I turned it to end onto her so that it wasn't so obvious, which basically aimed at east. After 3 weeks, it was very noticeable that I just wasn't receiving stuff. So I turned it back north again and it was fine. So even in the short DX path, it's quite directional.
Cool. Thank you very much, Steve. We show our appreciation.